Good afternoon. My name is Carl Sink. I'm in the Office of Advanced Reactor Deployment, and I'll be presenting this afternoon on the topic NE-2 under Program Supporting Nuclear Energy. And this topic deals with nuclear renewable hybrid energy systems. And my laboratory counterpart is Shannon Bragg-Sitton at the Idaho National Laboratory. Hybrid energy systems were first investigated to try to find ways that nuclear energy could contribute to the energy supply in ways other than strictly by producing electricity. While that's still a goal, our focus is now on balancing the grid and dealing with issues of nuclear power plant operations with flexible operations that are due to increased amounts of intermittent renewables being used on the grid. Nuclear renewable hybrid energy systems are being designed that can direct thermal and or electrical energy in real time to provide responsive generation to the power grid. The anticipated benefits include dispatchable, flexible electricity supplied to the grid, synchronous electromechanical inertia for the grid provided by large rotating machinery such as has been usually used in nuclear or fossil fuel plants, a reduced industrial sector carbon footprint, and stabilized energy costs. So looking at the diagram here, this is a typical hybrid energy system with all types of different components included. And one of the major goals then, as seen on the left, is to replace peaking power reserve currently provided mostly by natural gas turbine systems with a hybridized baseload system. In this way, you can direct heat and electrical energy dynamically to where it is needed in real time. It also can produce valuable industrial products as seen down in the lower part of the diagram, with nuclear energy that would otherwise be idled during periods of high renewable energy production. So as part of this program, the national laboratories are currently conducting R&D in the following areas: hybrid energy system design, that is the components that would go into a hybrid energy system, and looking at this on a regional basis, such as you would find that the predominant types of renewable energy sources are different in different parts of the country. Optimization of the configuration and operations by using system modeling to evaluate the systems as they're set up. And then testing of promising hybrid energy system architectures and technologies. And this is a part of the program that is planned for a little further down the road, but we're still looking for help to get ready for that time. So through this NEIP process, the lab researchers are hoping to work together with university researchers to bring new solutions to hybrid energy systems design, optimization, and demonstration. The scope of this solicitation has two main interests: development of modeling and simulation tools and techniques, and development and testing of new technologies that can be incorporated into hybrid energy systems to improve their performance. Now, some constraints to keep in mind when you're putting together these proposals. For the modeling and simulation scope, the modeling tools and architectures are already been developed by the national laboratories using the RAVEN modeling system developed by Idaho National Laboratory, and a common laboratory tool called Modelica. So anything that's proposed needs to be able to be used together with those tools. The deliverables should include modeling and simulation components that are ready for integration into the overall hybrid energy system model architecture. And as I said before, key contribution areas support longer-term needs, but as necessary could be integrated with the broad laboratory tool set as soon as they're available. For the technology feasibility scope, we're targeting low TRL technologies that are currently in the conceptual stage and must be demonstrated at the bench scale prior to integration with a hybrid energy system. And these would be experimental activities. It could include both bench scale experiments and corresponding model development for those systems. So looking specifically at the modeling and simulation scope, the specific areas of interest for proposals are as follows. Development of additional detailed component models to support integrated system evaluation within the hybrid energy systems modeling and simulation framework that would be within specific geographic regions of the country. These could include energy storage systems, industrial processes, and so forth, and then translating the mathematical models into compatible Modelica models. Another area would be evaluation of the economic potential and advantage of new process designs with heat storage over the baseload electricity production. The third area of interest is characterization of dynamic energy system behavior to determine the impact of thermal cycling on components and subsystems on component and system robustness, resiliency, and response rates of the overall system. In support of the hybrid energy system demonstration scope, the areas of interest for proposals are as follows. Scaled studies of energy storage concepts, for example, a scaled down version of a thermal energy storage concept that could later be integrated into the Dynamic Energy Transport and Integration Lab at Idaho National Laboratory for integrated system testing. Other area of interest is temperature amplification technologies, such as chemical heat pumps that can allow conventional light water reactors or near-term small modular reactors to support a wider range of primary heat or a wider range of industrial applications. So options to be looked at here could include upgrading of waste heat or the primary heat from the systems. These should give consideration again to operational, regulatory, and safety constraints associated with an operating nuclear power plant. So we look forward to seeing if there's potential interest in supporting this topic. Thank you.
Okay, please submit your questions for Carl to the GoToWebinar question section of the GoToWebinar application. Carl, under the area of tools for Raven and Modelica, are models of commercially available energy storage technologies only of interest, or are lab stage technologies also relevant here?
Lab stage technologies are relevant as well, as long as they are pertinent and applicable to something that could be found in the real world. But if something is a new system that hasn't been tried before, that would also fall under the second area of interest for demonstrating low TRL level activities.
Are there specific subcomponents of hybrid systems for which models are sought?
Not at this time. We're really looking for something innovative that could come from the universities. Currently, a generic reactor model has been done. The models of existing renewable energy systems from wind and solar have been done. On the energy storage and production side, they've already done models of a solid oxide electrolyzer. Other than that, there's a lot of other opportunities to be done.
The call mentions thermal storage. Are other storage technologies of interest as well?
Right now, thermal storage is the one that we're most interested in getting new ideas for.
Is there an available list of existing component models that are already integrated into Raven or Modelica?
That's a very good question. We would need to, if you send your information for how to contact you, we can get that list from the researcher at INL.
Are distributed renewable energy systems, i.e. rooftop solar, of interest here?
Not so much, mostly looking at large-scale systems, renewable energy systems.
Are dynamic models for the evolution of renewable with nuclear capacity of interest?
Can you repeat the question?
Are dynamic models for the evolution of renewables with nuclear capacity of interest?
Yes, that's pretty much specifically what we're looking at, but these, as I said before, the models should be compatible with the work that's already being done in Raven and Modelica.
Are partnerships with industry or national laboratories required?
No, not required.
Is there more information available for detail? The Dynamic Energy Transport and Integration Laboratory. Is this an existing experimental capability at INL?
The detail lab is still being assembled at INL. There is information available as to what will go into it when it's actually constructed. But it is a small-scale dynamic loop, which includes battery testing for electrical simulation, real-time simulation of renewable energy sources, and a thermal loop simulating a reactor and reactor response.
Is system safety analysis of interest in the modeling and simulation part of the scope?
I can't say for sure on that. I would have to see what is proposed and have that looked at by the researcher at INL. That's not specifically in the call, though.
Is there additional incentive for evaluating options that have potential international collaborations?
No additional incentive for that.
How many awards are expected in this area?
Will likely just be one award.
We'll stay on the line for another minute or so to take any more of your questions, so please submit them now. Is the operational safety analysis for the load following mode for the NRHES of interest?
Can you repeat the question?
Yeah. Let me see if I can reword it a little bit.
Is there interest in looking at load following? Yeah, that would be in terms of how energy storage systems are used in that, or if there are specific components that are to be modeled to look at that.
Is operation and control strategies development of interest?
No, not at this time.
Are improved reactor dynamic models of interest in the modeling call?
Yes, that would be of interest.
Are battery systems of interest?
I think there's a fair amount of work being done already in batteries, but depending on what type of battery system is being proposed to look at, that could be of interest.
And to clarify on the international collaboration question, there is additional consideration given in the pre-application and full application relevancy review on industry, international, minority serving institution, or underrepresented group collaborations. So that is outlined in last year's FOA. If you are not familiar with what kind of points and what kind of structure is given in the review for those collaborations, but essentially any non-traditional partnership is encouraged through the FOA as a whole.
Good afternoon. I am Brian Robinson. I will be giving the presentation today over the NE-2 proposals for molten salt reactors. The program mission, I'll read it right from the side, to research and develop advanced technologies to significantly improve the efficiency, safety, and performance of advanced reactor systems. The point of contact for RC2 is the program director, Alice Campanetti, myself, Brian Robinson, and then our technical POC will be David Holcomb. Our programs are working to address several high-level questions. I'm going to go through these just so you can understand some of the fundamental issues that we're dealing with molten salt reactors. How can we improve the affordability of nuclear power? How can we improve the inherent safety of advanced nuclear reactors? How we can improve the proliferation resistance of advanced reactors, which is a very important issue to address with molten salt reactors. How we can expand the nuclear technologies into non-traditional nuclear energy markets, potentially like smaller markets similar to the SMR. How we can increase the performance and efficiency of advanced nuclear plants through materials, advanced systems, or components. Our interest with working with the universities has been focused on a few technologies. We want to identify, characterize, and qualify successful salt and material combinations. Right now we have at least 3 areas that we're focusing on with fluoride, chloride, and thorium. We want to develop an integrated reactor performance model capability that captures the appropriate physics needed to evaluate plant performance over all appropriate timescales and licensed designs. We would like to establish a national salt reactor infrastructure and economy that includes affordable and practical systems for the production, processing, transportation, and storage of radioactive salts constituents. And lastly, license and safeguard framework development to guide research, development, and demonstrations. We found that these 4 elements are very important, and we think that they focus the research of the universities the best. More specifically into the areas, I provided some very topographical ways to explain our scopes of work. I'm not going to go into them, but they will be on our site. Development of thermochemical database for understanding salt behavior in MSRs. The thermochemical models and values are needed to predict MSR characteristics. Now those could be specific to fluoride or chloride more specifically. Thorium at this time is a little a fuel characteristic that we're not as interested in as we are the historical legacy of fluoride and the new advancements in our chlorides. Secondly is innovations in MSR fuel salt capsule irradiations. One of the things that we would like to do is look at ways that we can accelerate and decrease the cost of fuel salt irradiation. The output of these projects will fold back into our R&D programs to support the advancement of advanced reactors. Examples of awards can be found for FY17 at the link provided at the bottom of this page. I provided 4 awards that came out in FY17. Those are specific to MSRs. Methods to predict thermal radiation and design, radiation heat transport and optical characterization, and bimetallic composite development and compatibility in flowing fluid. So all of these were specific to MSRs, and I would like to provide those and this link so that people who are interested in applying will have a base and a foundation. That was a pretty quick presentation, only about 5 slides, but at this time, whoever's on the line, I will take questions.
Okay, please submit your questions now if you have them. We will stay on the line for several minutes to answer anything that you have. Brian, what specific materials are of interest in regards to corrosion?
Right now, Bill Corwin and Sam Sham is our lead materials people. Oak Ridge is our point of contact also, and We can get much more specific into the details of those because we have, that question's little bit difficult to address directly because we have ongoing research. We have research that is literally being evolved and handed out in other awards in addition to program activities. So for that question, if you would like to get in touch with me more specifically, I can get you details very specific to either the materials that you're interested in or the point of contacts that would answer that question.
And as a point of reference, Bill will be giving a presentation tomorrow at 11:30 on advanced reactor materials. So that question can be asked there as well. Is there a preference given to neutron versus ion irradiation for fuel salt irradiations?
At this time, we're in a data capturing mode. I don't believe we have any preference of one or the other.
Is optical characterization of salts with corrosion products of interest?
Yes.
Is the thermochemical database focused on experimental or modeling aspects?
Well, to answer the second question first, second part of that question, and not to be a stickler, but it's hard to make modeling equations without having empirical data. So I would say that both of them are very important. I certainly would lean on the first one the most because modeling, if done correctly, should have a lot of quantitative and empirical data to support it.
We'll stay on the line for another minute or so, so please submit the questions that you have right away. Are particulates for corrosion expected?
Again, I think that is an issue that Bill Corwin probably can answer better than me because he is our material scientist. I would lean to saying yes to that issue, but defer to Bill to give the details of that answer. Bill will be on tomorrow giving his part of the presentation at 11 a.m.
For RC 2.2, is there a preference on fluoride fuel salt or chloride fuel salt?
The overwhelming information that we have in our legacy for data mining will be support fluorides. We currently have many projects that are supporting the chloride fast reactor version. We don't have a preference to either. We'll be accepting information to support both, but I wanted to provide that much of that detail and legacy of information over the last 50 to 60 years could probably be mined from OSTI.
Particulates change the transport of thermal radiation. Are models that encompass particulate scattering of thermal radiation of interest?
Yes, I would say that would be of high interest to us.
Okay, Brian, I think that's all the questions. Oh, hang on, we have one more that just came in. For RC 2.2, should the thermophysical property measurement be separated from fuel salt irradiation measurements?
I think the separation would be a necessary part to accurately quantify that information and send it forward to us. The mechanism of which you do that probably would be should be reported so that we can fully understand if they are separate or combined.